Hello, in the last video we defined what are pushdown automata and explained how are they used to recognize context-free languages via examples, and we arrived at a very interesting theorem which states that a language is context-free if and only if it's recognized by a pushdown automaton. By definition, a context-free language is a language generated by a context-free grammar. So to prove this theorem, it suffices to prove that we can convert from a context-free grammar to a pushdown automaton and vice versa. In this video, we'll focus on the first part, which is how to convert from a context-free grammar to a pushdown automaton. Remember that a context-free grammar is a string generator. So in general, if we have a grammar, we can generate strings. And this is possible via making derivations. We start by the start symbol, here S, according to this grammar, and we change each variable by the symbols that appear on the right-hand side of one of its rules. We repeat this operation until we find just terminal symbols. This set of terminal symbols constitutes the generated string. So here the set of all strings that can be generated from the start symbol constitutes the language of the grammar. So for us to define the pushdown automaton, we need to define what are the operations that will be done on the stack. What will be popping and pushing while we are reading the input. So here the idea is to push the start symbol, here it's S, and then make substitutions. What does that mean? It means that we'll apply this rule. S is substituted by AB. We will pop the symbol S from the stack and we will push the two symbols AB. We have to push B, then push A in the reverse order of this rule, because the next symbol to be substituted here is the leftmost symbol. It's A. So we need to push the symbols of the right-hand part of the rule in reverse. Then for the variable here on top of the stack, we'll do the same. We'll pop it and push the symbols that appear on the right-hand part of one of its rules. It's a matter of guessing here what is the rule to be used. For example, let's say we will use the rule A is substituted by capital A, small a. So we'll push these two symbols, A, in reverse. We will push the terminal A, then the variable A. Again, we will have a variable here, so we will pop it and we will push the symbols that appear on the right hand of one of its rules. And in this case, we will pop the variable A and push the terminal A according to this rule. Now we don't have a variable on top of the stack. Instead, we have a terminal. In this case, the idea is to match this terminal. We cannot substitute it, it's not a variable, but we can match it with the symbol of the input. If you have A here in the input and the symbol A in the top of the stack, so we'll pop this small a from the stack and advance here the reading from the input. Again, we will have here in the input the symbol A and on top of the stack the symbol A. Again, here we will match and we will go to the next symbol. We will read the next symbol and we will read here from the top of the stack what will be the symbol. If it's a variable, we'll do the same as before. We have to change this variable. We have to substitute it, pop it, and push the symbols according to the right-hand side of the rule. Again, we will have a variable b, we will pop it and apply one rule and push the symbols according to this rule. Here it's a non-deterministic choice. The machine shall be given the possibility to choose between many rules for the same non-terminal symbol. Remember that the formal definition given for pushdown automata allows for non-determinism, and the machine needs to find a way to accept the string. If there is more than one way, the machine will try them all, and if there is one way that leads to an accept state, the string will be accepted. In our example, we know that we want to lead to the string A triple B. That's why we have chosen to replace the symbol B by the two symbols capital B, small b. The last B here, for example, will be popped, and the terminal B will be pushed. And this time we will see that this will be the same as the symbol of the input. So we will match, and we will match the second symbol, the third symbol, according to what is on top of the stack, until the stack will be empty. In this case, we will accept the input. Of course, the accept here does matter only if the input is finished. So to recapitulate the idea here, we will push the start symbol of the grammar, and then according to the top of the stack, if it's a variable, we will make substitution. That means that we will pop this variable from the stack and push its right hand symbols in reverse to the stack. If the top of the stack now is a terminal, we will match it with the next symbol of the input. We will repeat this until we have a stack empty. In this case, we will accept the input. Remember here, to make substitution for a variable, we have to push the right hand symbols in reverse. So if, for example, we will substitute S by the two symbols AB, we need to pop the symbol S from the stack and push the symbol B, then push the symbol A. These symbols have to be pushed in reverse. For sake of simplicity here, we will write just pop S and push the symbols AB. It means that we will push the symbol B, then push the symbol A on the stack, without here reading any symbol of the input. Now if we see a terminal symbol on top of the stack, and we are reading from the input this symbol, we will say that this symbol small a has to be read from the input, and the same symbol here a small has to appear on top of the stack. This symbol will be popped if we take this transition, and this symbol will be read, so we'll advance here the input to the next symbol, and we will pop the symbol from the stack. The result of the stack will be this one, and this time we will also match the symbol to read with the symbol on the stack. Here is the symbol to read on the input, and here is the symbol on top of the stack. Now let's draw the complete pushdown automaton given a context-free grammar. In general, we will have these steps for any grammar given. In the first transition here, we will push the $sign symbol. Remember, this symbol is used to track if the pushdown automaton is empty or not. So it will be pushed in the beginning, and at the end, before accepting, we should find this symbol on top of the stack. Then we will have to push the start symbol of the grammar. Here the start is S, so here epsilon epsilon S means that we will not read any symbol of the input, we will not pop any symbol of the stack, but we will push the symbol S. Here in this loop, we will allow the machine to pop any variable and push the symbols that appear on the right hand side of the rule of the given variable. So we will write all the possibilities here, since we will have 5 rules, 1 for the variable S, 2 for the variable A, and 2 for the variable B. We will write all of these possibilities, and then we will match in case we have terminal symbols on top of the stack. So if we have the symbol A on top of the stack, the symbol to read and the input should be A. In this case, we will advance the input to the next symbol and pop the symbol. We'll do this for the symbol A and for the symbol B. And we'll do this for all the symbols of the alphabet according to the given grammar. And finally, as we said, we will accept if we find the dollar sign on top of the stack, and of course, if we have completed all the symbols of the input. Here we may check that the string AA can be recognized by this pushdown automaton by tracing the advancement of the states, the input, and the symbols on the stack. Okay, so we can verify here easily that when the input is finished, we are in the final state and the stack is empty. So the general rule here, given any context-free grammar, we may draw the pushdown automaton in this way, and in this loop, we will write for all the rules x derives w, epsilon x push w. Push all the symbols on the right-hand side of the rule. And for every terminal A, we will write read A, pop A from the stack, and push nothing. Please note that we can simplify this machine by associating these two transitions together. We may write only one transition stating that we will push S dollar. Remember, pushing S dollar means that we will push the dollar sign, then we will push the start symbol S. So it's the same as these two transitions.